So good afternoon, everyone. Thank you very much for being here. I can now stop this. Yes. So we are here on the occasion of the International Day for Women and Girls in Science by the United Nations. And we are here with five researchers from the Astroparticle and Cosmology Laboratory of the University of Paris and CNRS. So I will briefly introduce them, and then we will start our conversation about their work, their research, and also the path that led each and every one of them to where they are now. I think we will have time for questions in the end. However, this is meant to be a conversation. So anyone that has a question, please either write it in the chat, raise your hand. If you are on YouTube, just write in the chat next to the video, and we will discuss. So here with us are Anne Lemière. Anne, can you unmute? Okay. Okay, Anne is there. So she's a senior researcher at the CNRS, so it's the National Center for Scientific Research in France, and she is the group leader of the high energy group of the APC laboratory. Next, we have Eleonora Capocasa. She's also a permanent researcher. She's an assistant professor at the University of Paris. And she works in the experiment Virgo for gravitational wave detection. Then we have Gwenaëlle de Vasseguet, who is Marie Curie individual fellow at APC laboratory, and she works on cosmic neutrinos in the KM3Net collaboration. Then we have Leila Egel, who's also a postdoc at the APC in the Virgo group. So it's gravitational waves, but she was more on data analysis. And next we have Catherine Guyan, who is finishing, sorry, there's somebody coming in, who is finishing her PhD also in the Virgo group, working on a more experimental side of noise reduction for the new interferometer. So first of all, we would like to talk about the science that you do. I think when most people think about astrophysics, they think about telescopes, I think in general, and they think about telescopes that see light. Now, this is a very different bunch of researchers. It's a different research that we do at APC, but let's say the closest to a telescope and the closest to studying light in a more traditional way is probably Anne, which works on gamma rays. So Anne, would you like to start us off and tell us about your research?
So I'm a gamma ray astronomer, actually. So gamma rays are the photons that are the more extreme of the multi-wavelength spectrum, the electromagnetic spectrum. We are really at extreme energy. And these photons are produced in the universe not by the heat of the dust or in the star, but by particles that are very energetic and that are accelerated in very special places in the universe, and that when they travel and they are accelerated, they produce photons that are very energetic. They are gamma rays. And so these places where this very energetic particle accelerated are the most violent object in the universe, places with very strong magnetic field and gravitational fields, places where there is a lot of matter and also a shock, like the very massive star's death, what we call the supernova or supernova remnants, what remains after the explosion, plasma shock, or also what is happening close to very dense objects like neutron stars or a black hole. And so these photons are not very easy to catch. there are not so numerous in the universe. That's why it's a very young field of astronomy, actually. It started in early 80s, and it's now completely really an astronomy field since 10 years, not more. So it's the beginning of something. So it's always very exciting. And as in other fields of astronomy, we are explorers of the universe, means that we ask to ourselves some very fundamental physics questions, but we also open a window, open our eyes to explore things. So we can also discover new objects that we have no idea from.
So I will start from the word you said, window, because in fact we often know in our field talk about windows and messengers, and gamma rays were the last window of the electromagnetic spectrum to be open to observations. And after that, and the other keyword, I guess, that unifies all of our speakers is extreme objects and extreme phenomena. That's basically what you all study at APC, I think. And these are common threads that unify. So after we open the whole electromagnetic spectrum, we are trying to move on. We are moving on to new messengers that are not photons. And so I would actually first go to Guyan and Leila as let's say, doing data analysis, and then we will go all the way to Virgo. So new messengers and new windows on the universe and on the most energetic events. Gwen, what is your research focusing on?
So I'm actually focusing on sources that might also emit gamma rays, the gamma rays that Anne was just talking about. But I look at another type of particles than light. I'm looking at neutrinos. So neutrinos are elementary particles, but they're very mysterious in the sense that there are plenty of neutrinos traveling and passing through our body at the time we are talking now, but they only interact with the matter once every millions, I would say. And so I'm also using a telescope, but the telescopes I'm using are cubic kilometer large. So imagine a kilometer over a kilometer over a kilometer. And they're either buried in the ice of the South Pole, for example, like the Ice Cube Neutrino Observatory, or immersed in the Mediterranean Sea. So clearly here we are dealing with a different concept of detection, because we use the medium, we use the ice or the water to be able to see these elusive particles that neutrinos are. So what else can I say? So Anne was saying that gamma ray astronomy is just at the beginning. You have to realize that neutrino astronomy is even younger. And so we only have a handful of neutrino sources known today. So we have the sun, obviously, that can emit low energy neutrinos, that is actually seen in low energy neutrinos for a few decades now. We have core-collapse supernova, close by core-collapse supernova, from which we can detect low energy neutrinos. We detect in total 25 neutrinos from the core-collapse supernova of 1987. And since we're still waiting for the next supernova sufficiently close to be able to see something. And we've also detected a blazar source emitting high energy neutrinos and gamma rays a few years ago, and that's it. So it's to give you a feeling of how hard it is to see neutrinos, and then even when you see some, so now we have, like in one of the most famous analyses searching for very high energy neutrinos, we have about 100 neutrinos detected so far that we are sure are coming from astrophysical sources, but we can point them in the sky. We can say, okay, they're coming from T specific direction in the sky, but we cannot associate them with a source yet. So that's the big difference, I would say, between what is done in gamma ray astronomy or in gravitational astronomy, as we are going to talk about, is that we have neutrinos, but we don't know yet where they're coming from.
Thank you, Gwen. And Leila, one more messenger, looking at somehow similar sources, in a sense, like extreme sources are gravitational waves. And that was the last window we opened in very recent years. Can you tell us more and more on what you do?
Yes, absolutely. Now we're going in an even more exotic phenomena because first, excuse me, my voice is a little broken, so I hope you will all understand me. As Anne said, and as you said, we think first about light, but even in light, it's a very big spectrum, has a different wavelength, and we have explored those wavelengths. Then we moved to astroparticles, notably with the neutrinos. And what I'm studying, gravitational waves, is even more exotic because here we're not looking at the particles that propagate in space-time. What we're looking is the deformation of space-time itself when we have some masses moving inside space-time. So I think it's very interesting to call these windows open on the universe because it's really this, it's really being in a room where you will have windows on different walls and you see a different landscape from each of these windows. And we are learning a lot of the universe with those different landscapes. And there were some windows that were a little more hard to open than others. So if neutrino astronomy is a new field, gravitational wave astronomy is almost a newborn because of first event, although they were predicted a century ago from Einstein equations already, we only could detect them 5 years ago. So this is an extremely new field of research where there is a lot of synergies to do with the other fields of optic and astroparticle astronomy, but that is extremely challenging, notably on the instrumental side. That's why I think it's really nice that we have Eleonora and Catherine who work on the instrumental, on the instruments, so they can explain us why it's so challenging.
Exactly. Thank you, Leila. So Catherine and Eleonora, so can you explain to us why it took 100 years from the theory of gravitational waves to the first detection? What were the challenges and what are the new challenges to improve our sensitivity to this kind of signals? I don't know which one wants to start, but Eleonora, maybe? Is she there? I think we lost.
Yes, okay. Can you hear? My connection is not optimal. So as Leila said, it was a major challenge, the detection of gravitational waves. The reason is that the displacement that we are looking for is extremely small. So we aim to measure a displacement which is much smaller than the dimension of a nucleus of an atom, and to do this we need to reduce all the external disturbances that can mask this signal. So just to some general detail, that the measurement is done with an interferometer. We use a laser that is able to measure the change in length of two orthogonal arms that are, we have mirrors, suspended mirrors that reflect the beam at the end of the arms. And then when the beams recombine, the interference condition tell us if the length of one arm to the other. This change, as I said, is small. And the effort that I've done in the past years or more as disturbances that can, as I said, mask this signal. The interesting thing is that there are many, these disturbances come from many different fields of physics. So it required an effort that went in many directions. So we have to take care of, for example, by reducing the vibration, the vibration transmitted to the test, and also the quantum noise that by the light that for the thermal noise. So it was a huge effort. It requires the help of many people and many also.
Eleonora, we do have a little of a hard time to hear you. That was a bit broken down. I'm sorry, the line is not very good. Eleonora? I cannot hear you. Can anybody else hear well? No.
Because
I'm sorry. The connection is bad. But maybe we can switch to Catherine. And Catherine, can you kind of tell us what you guys are doing right now? Because it's kind of amazing what you're doing to reduce some of the noise that Eleonora was talking about.
So we are working on one type of noise called quantum noise. So it is one of the major sources of noise. So when we work on noises, is to have more sensitivity, and when we have more sensitivity, we can detect more sources that are way far than what we can detect. And this quantum noise is originated from the quantum nature of light. So the origin of this source of this noise is the fluctuation, vacuum fluctuation that enter the interferometer, and so to reduce this noise, we have to beat something called the standard quantum limit. So it's a lot of it's a bit complicated, but to do that we will we use an optic bench. We use a lot of optics in this bench, and we create a special vacuum that is that we inject inside the interferometer, and that will reduce the quantum noise. So it's a little bit complex to explain, but this is what we are working on now. And this noise, so this technique is called squeezing, and it's a bit complicated because we have to know about the Heisenberg uncertainty principle. But this technique has been implemented in all the interferometer, in Virgo, in LIGO in the US, and then this technique is working. And for the recent observation run, it allows, I think, to increase the detection rate, I think, by 15%, if I'm not wrong. So this is what we are working on. And for the next upgrade of the detector, we are working on another technique to reduce this noise, but in a bigger bandwidth. And so this technique, and Eleonora was working on this new technique on Tama, another interferometer in Japan, and this technique works. And now in Virgo, for example, they are constructing the new component that is needed, and that is what
yeah, thank you. It's very impressive. So then I will switch to a few questions that I have for you, but can you give our audience a sense, because you all work on different messengers and aspects of the same problems. Can you give us a taste of what a multi-messenger approach is? I'm thinking of one event that is familiar to all of you. Yes, okay, I don't want to talk about it. I want you to explain what a multi-messenger approach is and how all of your different research can be connected to understand the universe, and alerts that are given from one instrument to others and so on. Maybe we go back to Anne to tell us more.
Okay, I can try. For example, we had a few years ago a gravitational wave signal from the coalescence of the merging of two neutron stars, let's say, neutron star and a black hole, and approximately at the same time, there was a very strong signal in gamma ray telescopes that is called a gamma ray burst, which is really a burst, a very luminous burst of emission at one time. These gamma ray bursts, we observed them since quite a long time now, but there was no, for this short one, there was hypothesis about their origin, but it was not completely understood, and was not clear, proved what was the origin of this burst that pop up in the sky. So there was some telescopes that aim to detect, to study this burst, but this time this was completely incredible to have this coincidence in time, and spatial coincidence between two phenomena with two messengers. And when we realized we had this kind of events happening, then all the telescope, everything, everywhere in the world, start to look at the same events, and neutrinos telescopes, photons telescope, but across all the electromagnetic spectrum, from radio to infrared, optic, X-rays, gamma rays, and every messenger was able to pick up some information, different information about the event. So, and we realized that this event was indeed the coalescence of two neutron stars, but that this coalescence provoked a gamma ray burst, and the interaction of this gamma ray burst with the environment provoked a lot of a cascade of phenomena that we could study all over the spectrum, and with many different messengers.
Thank you. Since it's already almost, it's 3:25. So I just want to move on slightly, and I want to ask to all of you, what brought you to your specific field? What excites you about that? And what, I would say, what do you expect from it? What are the next things that excite you about where your research is going? So Anne, let's start from you, and then we do like a tour of the table. Why gamma rays? How did you get there?
At the time I made my PhD, actually, it was the time when we really opened the window for gamma ray astronomy. So it was very exciting. It was also, well, the exploration of a new aspect of the world. So just that was already really nice. And right now, my research focused on the origin of cosmic rays that are particles that are everywhere in the universe, and that have a very important role in all the equilibrium in the universe, and they interact with a lot of objects, and they are central for me in the equilibrium of the galaxy, for example, because I'm focusing on our galaxy. And up to now, people have the big picture where that cosmic rays in the galaxy were produced with the death of massive stars in supernova remnants. And now we have some indication that perhaps it's not completely true, and perhaps what is happening at the very center of our galaxy, where we have a supermassive black hole called Sagittarius A star, perhaps it has influenced the production of cosmic ray and the galaxy in a very deep way. And so this, what I really like in science is when you have a kind of paradigm, and then you start to observe something that is not completely aligned with this paradigm, and then it's exciting because you are doing really science. So this is what I like.
We usually prefer when things don't work the way they were expected. So
exactly.
I got it. When I would go to neutrino physics now. Well, astronomy.
So yeah, I've always been very curious when I was, since I'm a child. And I've always been asking a lot of questions, and I was especially interested by the stars. So it was kind of obvious and expected that I would go in the direction of astrophysics. And so I started to do physics studies, and I've discovered neutrino a bit by chance. And this experiment at the South Pole, in the ice of the South Pole, which is also kind of magical. So you can detect particles produced in the universe with instruments buried in the ice. And it was enough for me to start my journey in this direction. And then you go on, and you discover more and more. And the more you discover, and the more you're interested and captivated by this amazing field that is astroparticle physics. And you might have already catch that from the conversation. Clearly, we are curious, but we don't go for the easy things. Each of our particular fields have a lot of constraints and a lot of challenges to overcome to be able to do physics with this particular messenger. And I think that's something that drives me every day to really try to overcome challenges. And what I'm really hoping to help building in my career is to turn these first steps of neutrino astronomy, where we only have a few events and we're not sure where they're coming from, into something that looks now like gamma ray astronomy, or I would say electromagnetic astrophysics, where we have enough events and enough information to really study what is happening actually in the astrophysical sources. So not just say, they're coming from this binary neutron star, for example. By the way, we didn't see neutrinos, but to say, but because I've seen these neutrinos in this energy range with these specific properties, I know that this mechanism was happening in the source, or like there was that amount of matter around the source. And so that's what really, that's what I'm looking forward in the next decade, or maybe 2 decades if I'm a bit less optimistic.
Okay, good. Leila, and then we go back to Katrina and hopefully Eleonora. I hope we can hear her, but we go to Leila. So why gravitational waves? I think there is a common theme that is what was really cool when I was starting my PhD, if I may say so, but.
I actually wouldn't say so in my case, because I didn't do my PhD in gravitational wave physics. I actually come from the field of particle physics. I was studying neutrinos like Guyan, but not even in neutrino astronomy. The neutrinos that were created were, we were creating them in accelerators. And but I think the common theme in what I'm doing is that I'm really interested in the fundamental level of how things work. And I've been like Gwenelle, always asking a lot of questions. I hesitated a little bit, should I go to philosophy? But I suspected in a way, I was seeing that the field of physics were also dealing with some of the question of philosophy. So when I had to take a choice, I decided I would give my chance to physics, things that I don't regret at all, because we have this opportunity that is quite rare to really spend our time wondering about why is the universe and the world around us the way it is, which I think it's an extraordinary chance to just be able to live this life. Then, as I said, to ask about those fundamental questions about the structure of our reality, there are different ways. So I started with particle physics. It was a wonderful experience. And as I was doing my PhD, the first gravitational wave event was detected. So I've been a little bit opportunistic compared to Eleonora and others, because I was not here to do the hard work. Well, I knew the field because I did my master thesis on the field, but then I didn't stay. I decided to choose something. I went to study particle physics. I mean, I was always a little bit back and forth between things from the sky and things from on the macroscopic level and beyond. And this, to me, was really an opportunity, because it was the first time we could really study the fabric of space-time. This was extraordinary, and this also had actually convergence with what I was doing in particle physics. We can search for things or looking in particle physics with a different way. So it's not exactly the same question, but we're basically having a question that is there that we sometimes know more or less how to formulate because we're looking for things we don't know. So sometimes you can ask a precise question and sometimes you cannot even, but you just have this feeling, more or less motivated that something is there, and you try to corner it with different ways. And what I find very interesting is linked to a question on multi-messenger physics is that with those different messenger, we can try to really corner those questions and try to dig to find, to try to answer the unresolved questions.
Thank you. Catherine, you really are doing the hard work. That's we can really say that.
I arrived after the first detection. So for me, it's a little bit by chance because I didn't really know what I wanted to do after, in which field I wanted to go. And then I had this job opportunity as a research engineer at APC, and it was on a space mission called LISA, which would be the first observatory of gravitational wave in space. And I remember that in my first year of engineering school, so I am an optical engineer, I did a lab work about Virgo, and we studied the interferometer, where the teacher explained a little bit the gravitational waves, and I was very amazed about this instrument, how it works. And so I saw this and I said, I want to do this. So I start working like this as a research engineer on LISA. And then I was there also when they announced there was this big announcement about the multi-messenger event, and we were in the auditorium at the lab, and it was a very big event. So it was a very very amazing work, and I wanted to do something more. And so I asked to do a PhD, and so that's why I arrived on Virgo. So now I'm on ground, but maybe it's easier on ground because the space mission is just its beginning. So there's not much work to do on the instrumental work part, because in my engineer job, I was doing a lot of simulation, and the instrument part, I missed it a lot. And then, and I also really like fundamental physics and the experiments. So I start to work on this quantum optics experiments, and this is very amazing. I had the opportunity to work very often on the clean room at the site of Virgo in Italy. So it's a clean room with a big bench, a lot of optical stuff and laser, and so it's very fun for me. It's also very it's challenging, and also I really like to learn a lot about astrophysics, because for me I thought that it was so too difficult for me. Astrophysics and this kind of thing is not for me. But with this instrumental part, I have the chance also to have the explanations of people working on the theory. I try to learn about, which is very hard for me, on the physics of gravitational waves, and so people explain the events, and to learn that I contribute a little bit on the instrument part, and that enables to detect so many events that are interesting, and this is more and more interesting, and this is very fun. And
yes. Eleonora, do we hear you? I hope so. Is Eleonora there?
Maybe yes. Can you hear me?
Now, yes. Let's hope it works.
Yeah, it's coming back and forth the connection. So
Go on.
I don't know. Maybe it's too complicated.
No, it's fine. So how did you get there? That will come later. This is the next question. But why this field? Why the things you're doing? And where are you going? Where would you like to go from here?
I started to, first I joined the collaboration. I started to work on Virgo just before the first detection. So it was very, very exciting to witness this epochal discovery. I was very lucky, I think. When I started to work in Virgo, I was in Pisa. Actually, it was because, of course, I studied in Pisa, and Virgo is close to Pisa. So in the university, I had the chance to talk with people involved in the experiment. But at that time, it was an experiment a bit, I mean, people were asking if the experiment would have been able to see anything. Yes, I remember there are many, of course, people inside the collaboration have strong faith that they will have arrived to the results, but people outside, also my colleagues at the university, I remember they are. So for me, it was very, very interesting, this aspect that was something not yet established as a result. And also at that time, I started with something more theoretical. So as Katrina said before, there is this part that is strictly connected to quantum mechanics. And so I studied quantum mechanics at university, and then I had this chance to talk with a professor who told me that this application in the improvement of the sensitivity of this instrument. So it looks to me a very fascinating thing, the fact that I can apply something very theoretical to something very practical. And this is the way I came to work in Virgo. And then from this theoretical work, I moved to more experimental one. It was a bit by chance also, because I want to explore new things after my master, and I found it was even funnier than before. So I'm happy with my choice. And can you hear me still?
More or less, a bit worse than before.
Maybe not.
Not so well.
Yeah. Anyway, I just conclude saying that I now that the field has opened, I think the most exciting part will arrive.
Yes. So I have 110 questions for you. Clearly, we will not be able to explore them all, but I wanted to switch somehow to your personal path here, because another interesting aspect is that not only you study different messengers, but as we have started seeing, you also have different paths, like any of us. And I would be interested in you telling a little bit of not just how you got in this specific field, but as a woman in science. So Gwen said that she knew very early on. Leila said that it wasn't clear to her until maybe the end, like she was torn between different things. So I would like to know a bit more about this. And I would also like you to maybe tell us, there are several things I would like you to tell us. First of all, what are the qualities you think, or the characteristics that somebody should have, and especially a woman should have, to do your job, to do this kind of job? And also, now I know I'm steering you a little bit, but I guess that it would be interesting to know if you ever struggled just in general with the field, because I think that many people, and this is regardless gender, feel, like Catherine said, like this is maybe too hard for me, or I'm not good enough in this one particular thing like maths or something. And I think that struggling per se doesn't mean you cannot do it, right? It's normal. You stumble, you struggle, you move on. So a lot of questions in one, but if you could give us a sense of your journey, of your path as a woman in science, and what are the things that pushed you through, maybe. I don't know. I think we start with Anne again and we go the same circle. I asked 110 questions in one, I realized, but go wherever you want to go.
Perhaps I can try with the quality to do the job, perhaps.
Yeah.
I think the principal quality is curiosity and motivation. I mean, I don't think there is really some technical barrier that you cannot reach if you're really motivated and fascinated by what you are doing. I think it's the principal quality. everything can be fixed except that. So if you have the faith and you have the pleasure to abstraction, to ask you some question, to observe the world, to ask how things are working, then you will be a good researcher. Technical aspect can be fixed. You just have to work, so it's not a big deal for me.
Have you always known that you would be a scientist, or did it came later in life for you?
I think I probably always known that I would be a scientist. I've been fascinated very young by the power of science, really the power that, I mean, when I'm doing analysis, I'm like a little child actually. Just realizing, when I realize that the photons that I have on my screen on my computer come from the galactic center, so it means 8 kiloparsec from here has been emitted tens of thousands of years from here. So I mean, you are touching there a time scale and a distance scale, which is completely has nothing to do with your human scale, you see. So this is really incredible to be able to do that. And so there is, in one sense, I mean, we are very lucky to live today, because there was a lot of work before us, a lot of humans that works to build science, to build the tools that today we can just use to continue. And we have also a big duty to the future humans that we also have pleasure to explore the things. So it's a big responsibility and a big change, and it makes sense for me.
Does anybody, let's shuffle things around. Does anybody want to comment on the qualities that you should have, and on the possible struggles you encounter, either as a scientist full stop or as a woman in science?
I think if I may start, that first I wouldn't have said better than what Anne just said.
Yes.
But one thing I might add is that we need resilience. And I think this is both for men and women. The way we're going to deal with it may be different, maybe, I don't know, but this is very important, because it's hard. It's hard, not in the sense of understanding itself, but in the daily life, because the work is amazing and being a physicist is amazing, and I wouldn't want to do anything else in my life. Like I'm paying to work on my passion, so this is just wonderful. But the everyday life might be hard sometimes, because you have deadlines, you have comments, you have to prove what you're doing is correct, you have to prove that the ideas, the crazy ideas you might have, will lead somewhere, and then sometimes the doors are being closed just in front of you. And it might be true for any other kind of jobs, but it is for sure true for research. You need to be resilient and be able to bounce back at every single doors you meet in front of you. And I think this is as important as motivation. It's a bit linked, and curiosity, in my sense.
Anyone else has something else to add?
Yes, I agree a lot with what Guyan said, and I think it's even in the nature of the job, because if you're doing research, it means that you will always go somewhere where you don't understand things, and in a way it's fascinating, but sometimes it's overwhelming. You know, sometimes it feels good when you're just doing something you're masterized. And no, you may masterize a technique. In my case, can be a statistical method or a certain program I've learned to use. There will always be a part of the job that is about being where I'm uncomfortable. So it can be overwhelming. And I think the way, at least me, I process is that you need to have your little team of people that are supporting you. It can be your mentors, can be your colleague, senior colleague, a colleague of the same stage. But it's very important to have people. We look very solitary, but a lot of us are working in big collaboration. And those collaborations are important for the work that we do and for the way we process it. It's important to discuss, it's important to share what we're doing, it's important to share the way we feel about it. And even when we are students, I think one of the best way to make use of the student years is, of course, to study well, to understand the material, but also to create connection during internship, to connect connection with the professors, to dare to go where you don't know much. Maybe you're sure you want to study a subject, but you just got the class about something and find, oh, actually this was interesting, and to dig a little bit, and you might reconcile it, like a little bit Catherine did with astrophysics and optics. So have different people around with whom you can chat when it's a little hard, when you have questions, when you have a good news, want to have people to celebrate with, is something very important and that you will carry for a big part of the career.
So am I right in saying what I said before, that you were not one of those that when she was like 8 years old knew that she would do science for a living?
No, I mean, in my case, I think science was always a fascination, and I think it's linked to the resilience that Guyan talked about, and to the fascination is. I always found science was fascinating, but then I always have a lot of interest. So taking decision is not very easy for me. So I mean, the fact that I choose science means that I'm really fascinated by it, I think. And that's a good thing. That's also, the time scale of what we do is also very long, which I think can participate sometimes to the fact that the job is hard, is that you get an idea. So one of my favorite part in the job is getting an idea, right? Is the creativity that we have. When you have an idea of, oh, what about we look at this? What about we try this method? It's really a thrill. But then to actually implement this idea, it can take weeks, it can take months, sometimes it's years. And so this is not easy when you are so quite an impassioned person, which I consider myself to be. And that's where I think being fascinated by what you do is really helping, because then if not, there are many opportunities to do another job, which will provide other type of advantage that maybe we don't have in this career.
Yes. I don't know if either Eleonora or Catherine want to add on these points, or I have plenty more questions for you and for everybody else. Something with Leila, and I think Guyan as well touched upon, is who inspired you to do science, or what events, or was there someone to support you? You know what I mean? Like, did you have to fight to enter science in your circle? I'm talking not on the job, or were you supported in your family, in your group of friends, your teachers? What was your experience, especially as a woman? Was it were you encouraged, or did you have to kind of fight your fight? Especially being an engineer, I would imagine that multiplies.
I can answer.
Yes, Catherine, please.
So I remember that before entering high school junior, so my parents wants me to be a dentist because it's less tiring than being a doctor, and it's a good job. And I said I want to be an engineer, and I really have to fight for it. And they said, because I had excellent grades in all subjects, because I like all that we study at school. And they said that girls have high grades in high school because they are serious, they work very hard and this kind of things. But when we go in university, boys will be better than girls in math and science stuff. So they said to me, now you have good grades, but maybe in university. So I have to fight for it. And at the end, they let me do what I want, and then they still support me. Sometimes they still say, with your good grades, you could have been a doctor, but engineer is good also. So.
Did anybody have a similar experience of somebody close to you that would actually point out that this is a boys' club somehow? Did that happen to any of you? Or did you have always support?
Honestly, for me, it was really the opposite. So
Okay.
I feel like I'm here, and it's not even because I did something to do so. So when I was a child, well, during my entire childhood, my mom always told me, push me to do better. And so, like, concrete example, if I had grades a bit lower than a boy, she would say, no, but you can do as good or better. And so there was never this idea of you cannot do it because you are a girl. It's like, I would say sky is the limit, but okay, in our case, maybe universe is the limit.
The big
It's like, exactly. So it's like, no, I was really pushed to give the best I could. I mean, I was not beaten. I had a happy childhood in this direction. No worries. But I was really pushed to do my best. And I must say that since I'm a very young girl, I received some books, some documents, some games about science and the solar system. And so I found back. Moving out, I found back some books written by people from the Observatoire de Paris. And so I find of like, okay, I didn't even choose what I wanted to do. It was kind of forced to me since I'm 3 or 4 years old. And so I was okay, I guess it was the path that was decided for me. I mean, I'm super happy with it. And again, there was no pressure, but it's really the opposite of Catherine. So I feel really lucky to have grown up in such an environment.
But then it leads me to another question. Was this, I'm sorry, I was about to call it a bubble. It's not a bubble, it's what it should be. But was it ever chipped on by something else, by the work environment, by colleagues, by professors, by, you know, like, because this is your family. I can say I had a similar experience, but I don't want to talk, but what I'm saying is that when you get to work, when you get there, there are tiny things. And I wanted also, like, related to this, know if you grew more aware of this as time goes by, because I look back to some things now that I didn't even, like, you know, I shrugged and move on. And when I look back now as a more adult person, more aware, I was like, that wasn't that right after all.
Well, that's the drawback of growing in a bubble where you are pushed to do anything, is that then you realize that the rest of the world is not like this. And so indeed, I mean, I've like had to hear that I would never be able to do a PhD, that I should consider changing physics studies to do something else, that I would never have a permanent position as a researcher at different levels. So I've heard that during university, during high school, by a math teacher, because I had good grades, very good grades in math. But the professor who did I should say the high school teacher who couldn't do a PhD thesis when he did said, okay, but you won't be able to do it. You are not as smart as I was, and I couldn't do it. So maybe it's true, but I did manage to do a PhD thesis anyway. And so, as you said, I mean, it's like thinking back, it's true that there were a lot of people saying, no, but you're a woman and you cannot do that, or you are that person and you cannot do that. And so that's also why resilience is important, because there will always be someone, either because maybe it's true, or maybe it's just being jealous or just being mean, that will try to stop you to go in the direction you want to go. And this is really important to keep in mind. If you want to go, just go, and you don't care about what the other thinks.
Does anybody else, we haven't heard really from Eleonora about this. Does anybody else anyway want to say something about this on the point of having to deal with kind of still a man-driven culture? I don't want to use too strong terms, like I don't necessarily want to, you know, be too strong, but it's a man-driven world, even in science, right? Where we kind of think of ourselves as being objective, like by definition. And that's not necessarily the case when it comes to human relationships, rather than black holes and gamma ray bursts. So does any of you want to bring their experience or make a comment on that?
What I can say is that there is like the obvious few people that remain and think that a woman can study, but once she has children, and she should stay home. So there are still few like this. Maybe less and less, I hope. I'm not so sure all the time. But I don't think that they're not the only thing that would create, that would just stop somebody. So of course, if one of your professors, like somebody influential in your life, has this type of opinion, this is really harmful. But even if you don't have this type of opinion, my family was very neutral about my study. I could study what I wanted, but we had no idea. So I don't come from a family of scientists. And when I was talking about research, I remember I was like, so should I do preparatory classes that we have in France? Should I go to university? What about after? And then we're wondering, like, is there any even research in France? Is it everything the US now? And I think it's before I could choose the thing that at university you have to choose what you do. And before I could choose, I wish I had more opportunity to be in contact with researchers, because I had a much more negative vision of the state of the field, that there was no research in France and would never find a job, than what it was. And then once you're in the system, there is, of course, there is what is called now unconscious bias. So I did have comments at the beginning of my study. I started studying engineering like Catherine before I did an internship in particle physics, in the engineering team of a particle physics lab, and then I decided to do that. And I found the engineering team are actually more sexist. It was 10 years ago, so in my experience, this was what happened. Still remember a mechanical lab where a whole wall was full of pictures of women without bra, topless. So this exists still, at least 10 years ago. Okay, at this time, I didn't care that much, but it was me, maybe if I was coming from a different environment or with different personality, it could have been, I don't think it should be, I don't think we should have this type of decoration in a public research lab nowadays. No, the thing that stop more, the thing that you start to wonder, as you say, when you go back is, if I was somebody else, would I have had different opportunities? Would I have had different thoughts? Sometimes you will have colleagues that will have thought about, they will just want somebody to collaborate. And all those unconscious bias, you cannot say exactly at this time you didn't take me because I was a woman. What happened is that you wonder if it was one of the reasons why they went to see your male colleague and not you. And that's only a statistical effect that adds up. And I think very little women can say it never occurred to me, but we cannot, it's a cumulative effect. And the best way to prevent against it is, well, there are things that we can do as a community that I have to say that now that we have this type of conversation, there is a little bit of movement, such as, for example, when somebody wants to do collaboration, explicitly saying it to all the colleagues, so everybody can apply for the collaboration is a good way. In general, being as explicit as possible, I think, is very good. And as a person, as a researcher, it's very important to be vocal. It's really important to not wait to be invited to the party, but just to actually invite yourself to the party. To put your foot on the door and to check if you can enter or not. And it's something that is really learned on the ground. And that's why I think having mentors, having people to advise, if you're like, I don't know, if some of the people here are master students or anything, you usually have few professors that would be very happy to give you advice, informal or, about the career and the science, or sometimes about larger things. And this is extremely valuable. That can make you save time or understand what you're getting into, and be very important for you.
Okay, it's already 4, unfortunately, but so if anybody wants to comment on this point, and then I would like to ask if anybody in the audience here or on YouTube would have questions for our speakers, that would be really nice. We would like to take some questions. If not, I could go on for hours, but I will spare you. But does anybody have questions?
Just can give a short reaction to what
Absolutely, yes.
about unconscious bias. I think it's indeed the most difficult things on which we have all to work on. And one way to do that, of course, is to talk about that. And because we have all integrated some images of what is the archetypal scientist, and usually we use some specifications that are unconsciously associated to men, like dynamic, like competitive, like things like that, that are very integrated unconsciously by us. So it's important to diffuse and to talk about the studies that are done on our bias. And there is a lot of scientific study that are doing, and they are not very
well known, and
they are known by people. So I think it's important to share that and to discuss about that, and to be careful also for the recruitment of scientists, not to search for always the same kind of profile, because we really need a diversity of profile to work together, not only one kind of profile. So it's important for women, but I think for also certain part of the men that are not completely in one species.
Yes, absolutely. It's completely true. I fully agree.
So I have a quick story to support what Anne just said. So I actually took one of these society study, if I may say like this, to see whether you were biased towards men, women doing art and science. And it seems that I'm strongly biased, and I like my subconscious thinks that men can only do art and women can only do science. And I work every day against that. I mean, that's a true story. And I work every day against that. And I also try to consider men application for students. So I promise, I really work on this.
Are there any questions from anyone? Don't be shy. Yes, Norma?
Hello, thank you very much. I don't have a question, I have a comment. So perhaps you don't accept questions, but I just wanted to say that I have a comment, not a question.
Yes.
I don't know if you accept comments.
I guess, yeah.
Thank you. Very interesting to know, I mean, all the experience from different generations, different these activities, and also different places. I would say that today, and with a very high international international experience from many countries, even many different continents and hemispheres. And I should say that it's very important, and that support what the panelists or some of them said. I think it's very important the family role in the family. I mean the closet, the families, the mother, the parent, the father, or the close family, the tutor, and also all the surrounding in the very children ages, or even adolescent. That I think is very, very important. Irrespective, I mean, of course, the cultural medium, the country and the cultural medium and so on, but the family more, in any case, more than the school education in the children or in the early ages set. In the primary school, even in the secondary school, I think is the, and then after in the different experience that accompany you very strongly to face or to support. I mean to solve all the questions of what I mean, that you came from a different hemisphere or from a different, I mean, all that is common to many, to man and woman, and sometimes more for humans, and often more for humans. By saying that, after that, in my experience, I mean, here I should say that the more difficult for women, of course, I mean, there is a question of children, of course, this is a difference. I mean, that is the state, the public, the institution need to provide support, facilities. I mean, you know better than me on that. But by saying that and summing up, I should say that the more difficult for a woman, or for a scientist, we talk about scientists, or for a man, is to be independent, is to have a mind which is independent, in an independent thinking, to be able to be yourself, and to be able to remain yourself, whatever the responsibilities and whatever the problems and whatever you are facing, or you are facing in the good sense. I mean, I am not talking about fighting. I'm taking facing the difficulties, I mean, or the problems everybody needs to solve. Life is a solution of problems in some sense. One part of life is that. And I say it's the more difficult for any woman and for any man. I don't know if for women more, because women are looked as more said, not too much independent mind. Independent in the sense that being able to point out what you are thinking about, even if that is not what the system is taking. But that, I mean, is my in some sense, is a fierty, and is a very important to be able to go ahead with your own projects, and to have your own originality, if you can. I mean, and that sometimes, of course, the institution will say the woman put yourself, and they put you are a woman, just, but if you are a woman to say what everybody says, and you are not able to say your own thinking, I mean, and that there are many women which are doing that, which prefer to have a prize, or prefer to have something to go ahead in their careers, by exploiting the fact that they are women who. But I think that is important point also to point out. I mean, it's my point.
Absolutely.
Yes.
Thank you, Norma. And we have the question.
Yes. Can I just say something about what Norma said? Yes, I understand. I have two things to comment, if I may. On the one hand, and I will try not to be ideological, which comes hard to me, I have to admit, but so there are studies and there are statistics that show that children of any gender their mind is shaped, and it's not that their path is written, because nothing is written, thank goodness, but are shaped very early on. So this goes in the direction of saying that, of course, family members and teachers, like even in kindergarten, are very important, and there is tons of literature, right? And I think we are disadvantaged from the moment that somebody puts like a pink doll in our hands rather than a train. So it's not always a choice to be independent in your way of thinking. But the second point is that in many countries, there is a very good access rate of women to scientific STEM studies. And then we have the famous leaky pipeline. So as a scientific community, maybe it's harder for us to do something at the level of society and education of very young children. But I think there is a lot of room for improvement in self-reflection and modifying and adjusting the culture inside science, inside academia, inside the labs. And that would already help to keep the women that started the career and then are dropping out. Yes, there are questions.
Yes.
So I wanted to get back to Elisa's question and in some more detail.
Sorry,
So
apologies.
Elisa is asking if what you would suggest, what are your suggestions that you would give to a young woman that is interested in working in science? So I guess, so one was really like, do it, but do you have...
Julia, sorry, I will collect another question from the YouTube
Yes.
lab, which is also very similar. So they ask, do you have any advice for young women looking to do science? I mean, as Elisa was asking, but also, is there anything in terms of research into university, anything in terms of skills that you should have to apply for science?
So if I may start, I think what we've heard during this conversation is clearly that you can follow different paths and still reach the same point or about the same point. I mean, clearly I did physics studies. Leila and Catherine said that they went for engineering. So it's two different career paths. The studies, I mean, of course you're studying science, but not really in the same manner. And still we're working in the same lab. So I think they're clearly different paths, and you should never consider that you have followed a dead end. You're always able to, well, you should always be able to change your mind and go back in the direction. So of course, if you start studying law, for example, it might be a bit more complicated to go back to science afterwards. But in general, I think there is really a room for change in early career of research. It's true that now, if I would decided to go and study something completely different in science, it might be a bit more complicated, but we are now also doing a lot of interdisciplinary projects, for example, where I'm personally working with biologists studying fish and bioluminescent species at the bottom of the sea. So this is really far from what I've been studying at school, and still we are working together now and helping each other with research. So I wouldn't say there is one single path or one single university to go to be able to do astrophysics or science at the end.
Anybody else that would like to add something?
Can you hear me? Maybe I'll try. No, maybe it's...
Go. Yeah.
No, I think it's very important to keep in mind that to do science, you don't need to be a genius. Sometimes this is a misunderstanding when you are in high school, and people are scared because they see scientists doing difficult things, but not all the science are genius. And it's important that even people that are not genius, and most of them are not, engage into science, because actually great results are built with the help of many people. So doing science is like it's not like doing Olympics. It's just a group effort. So you don't need to be extremely, I mean, much more much better than other, but you need to just be interested and able to involve in a group that has an aim and wants to learn more about universe. Or so I think this is something important, not to be scared.
I think it's a very good point, and I think that women in particular, for many reasons, tend to censor themselves. There is another study that shows that for jobs applications, usually now the numbers I'm saying are not correct, don't quote me on this, but basically the message is, imagine you have a list of skills you need to have to apply for a job. On average, a man would apply with, say, half of them, and a woman would only apply with 80% of them. Do you know what I mean? We tend to think that either we are absolutely excellent at something, or we shouldn't even try it. And this is really not the case. And I think if we can summarize what you said, I think curiosity, motivation, and resilience, and I would say being stubborn is another way to say it. It's much more important than being a genius or being absolutely like skilled in an absolute sense in maths, for instance, or something like that.
Yes,
So
yeah,
go ahead.
I just want to summarize that with just one sentence. When you apply to any job or any kind of proposal, don't think about what you think you are, but think about what you want to do. So if it's something you want to do, then go ahead, and people will decide if you have the good profile or not. But you don't have to decide on yourself. It's not the point. So it's true for men.
Very good point, and very good point. Yes. Don't limit yourself. Say what you want to do, try and do it. And if somebody has to stop you, let it be somebody else. They will do anyway. Are there any other questions? Yes, Leila.
Yeah, I think it's all, as you say, you just try it at the beginning. Like don't prevent yourself from trying things. It's extremely important to try things. And that's why I think in terms of a little bit more hand-on advice I can give, I mean, more concrete advice I can give is that if you're interested by research, try to do internship. Internship is really a moment where you're going to spend some time with a research group, and you're going to see what is research, and you're going to decide if this is something you would like to try more, I would like to say, or not. And when you're talking about being a genius or math, I think it's really correlated, because I also had this idea that astrophysicists were extremely proficient in math. And my math teacher, I remember, was very all about demonstration and all about the best school in math in the country. And I was not actually very good in demonstration. I was not really interested in math. I was more interested in theories and how can we measure things. And when I actually went into a research lab to do internship, I realized first it's much more about programming or electronics than I thought. There is not a lot of people who spend time with the pen doing the calculation by hand. And actually the math that I use now are much more applied math. It's about analyzing function or things like this, which are actually the things that I like to do in high school and that I was good at. So doing an internship is going to show you what is the reality of the job. What are the skills you're going to need to develop? So I don't know if you are interested in biology or in physics or in what, so it really depends on what you're interested in. Maybe if you're here, you're more interested in physics. So according to the subject you prefer, you will see what were the skills of the people there, and you will be able to develop them. And to find an internship, it's a good time to indeed go to your professor and say, I'm interested in doing research. I would like a previous experience as an internship at university, in our university. If not, consider if it's possible to do an internship somewhere else. It depends a lot on funding. Few internships come with funding opportunities, not all. But doing this research is going to be a preparation for when you will look for a PhD. And if after you continue to do a postdoc, to look for a postdoc and all this. After, with all that we say, I think that we should also be very realistic, because one thing that I've never had when I studied physics, and I was in a master that was specialized for fundamental research, is that we are not given the prospects to have a permanent position. And those are very low. I think that from people who do a PhD, it's about 10% who get a permanent position. Those are extremely rare. Yeah, I think, but we're also in a paradigm, in a life where now, our generation, where we don't keep the same job forever. I don't know if I will become a permanent researcher. I know that I'm very happy that I had at least about 10 years of my life where I have spent it trying to understand the future of the universe. It's a really appreciable time. And when you do that, you learn skills. If you're interested in doing a PhD in science, the rate of unemployment, if you leave academia in this case, is extremely low. You are learning skills in science, in biology, in health, in computing, in analyzing scientific literature, in working in collaboration, in networking, that are extremely valuable for careers in academia and outside academia. So do not think, oh my God, there is just so little position in CNRS or whatever that I will not try. I mean, if you think it's not gonna be enjoyable, then don't go. If you think it might be enjoyable, yeah, try it. Anyway, it's a job. You have a contract. You always can leave if you find something
I think
better.
this is a very good point, and I would like to bring my 2 cents because I am one of those of the many, of the majority maybe, that did science and then left for something else. But I want to, like, subscribe what Leila just said in something we haven't talked about right now, because you are succeeding in science, which is great, is that if it's something that you like, and if it's something that you think you might enjoy, do it, because there are many jobs, many more than you can imagine, that will open up to you, even if you leave active science, because you had those skills, because you learned those things. It's very rarely a dead end. And while you do it, you might find out, which was my case, that I liked the thing in general, but I didn't like the daily, like day in, day out routine of it. And I found something else, and I'm still there. And so that shouldn't be one of the reasons why you do not try, that there are few jobs or that might get hard, because very likely you will bounce back on something that you love anyway, that is connected to what you studied, if that makes sense. I want to maybe close on something completely different, but I found it very nice. So somebody's asking on YouTube, what do you think about the movie Interstellar? Is that accurate? Is that close to reality? I love the movie. What do you guys think? Well, the guy did win a Nobel. I mean, Kip Thorne, so.
Yeah,
what I can say is that it's very accurate, yes, because it was, the Nobel Prize, Kip Thorne, was involved in the writing, so he did the simulation on purpose, and so we can say it is very, very accurate.
Yes.
Maybe Leila was saying something.
If I can comment, just I think one thing which is not really current or how can I say real, is that it's everything depends in this kind of American movie, because it's the American way of seeing life. It's everything can just be into one personal success or one personal achievement. And I think today science is much more in what is happening between peoples. And if at one time someone, you were talking about genius, Eleonora, later on, early on, sorry. Actually, when you have this kind of genius, usually he is created by the community. This is just someone that at one moment have synthesized many ideas that are circulating between people. And so the collective aspect of science, I think, is not enough discussed and realized by people. So I think it's very important, this aspect, this collective aspect, the fact that we are human, that are communicating with each other, that we are exchanging ideas. Ideas are there around, and at one time, because of everyone, one people will have perhaps just one step to go further, but there is this collective with ideas that is very important in science, and that is not really in this movie, because it's just one.
The hero, yeah.
Yes, one hero. I think this is not really true.
So if I may just add something, because I was a bit not shocked at all by the word genius, but to me it doesn't really have a sense, because maybe, okay, the common meaning is someone really good at math, but at the end, if we would, and that's what Anne is also saying, if we would only have people very good at math, we would have never built Virgo, we would have never discovered gamma rays or neutrinos. And so I think each of us is a compilation of different skills, and it's this specific compilation of skills that would make you a good researcher or not. Whether you're good in coding, in having ideas, as Leila was saying, or in communication and explaining your ideas, this is different things. And And we need everything in science. If we would be only good in one single direction, we wouldn't be a good physicist, in my opinion. So don't be afraid of not being a genius in just one direction, even though genius can be such a general word.
Thank you. I think we need to close. It's almost 4:30. So I would really like to thank you all. This was wonderful.